Alright, in this video we're going to learn what is called Charles's Law, and we're going to do this very similar to what we did with Boyle's Law. In Boyle's Law, you learned how to work with the formula. That's what we're going to do in this section. Now, what I'm about to show you is very important. You want to make sure you write down. Notice Charles's Law, which you already have in your notes, is V1 over T1 equals V2 over T2. The very first thing you need to know is the answer to this question. What is constant? What didn't change? Well, if you remember a few days ago, we talked about pressure, volume, and temperature. We talked about all the pressures, all the volumes, and all the temperatures. Which one of these is not in this formula? Well, you will notice pressure is not in this formula. This is a very common question that is asked of students. What is constant? Which means it doesn't change. I have a volume, and it's changing, and a temperature, and it's changing. Pressure is not even in the formula, so that's what's constant. The easy way to know this answer is what is not in the formula is what is constant. So quick question for you. If we go back to Boyle's Law, P1 V1 equals P2 V2, what is constant? Well, what's not in the formula? The answer? Temperature. Temperature didn't change. So when we work these problems, you're going to find it's going to look like similar math, but the law is very different. V1 over T1 equals V2 over T2. First thing you need to put a star. Temperature is always in Kelvin. Make sure you get that down. Temperature is always in Kelvin. A couple of days ago, we talked about the Kelvin scale. I'll walk through it again here in a second. But if you work a problem in Charles's Law and you use degrees Celsius, it will always be wrong. Charles's Law only works with a law that can never be negative. Now, quick reminder, let me show you why very quickly. We talked about the other day that there is the degrees Fahrenheit, degrees Celsius, and the Kelvin scale. We never use this one in science. This one is based on 0 to 100 degrees Celsius. The Kelvin scale is based on the absolute coldest temperature in the universe, which was negative 273.15 degrees Celsius. You should remember this. So basically, degrees Celsius plus 273.15 equals Kelvin. If you don't know where you put that in your notes, make sure you write this formula down. You're going to use this over and over and over in Charles's Law problems. You have to be in Kelvin. All right? So let's work a couple of problems. Here's our first example. A gas has a volume of 5 liters, 5 liters at 200 Kelvin. If volume changes to 6 liters, what is temperature 2? Now, if you'll pause the video for a second so that everybody can write this down, we'll come back and work it here in a second. All right, first thing you want to do, just like always, write your formula down. V1 over T1 equals V2 over T2. Here's why. It is a different looking law than Boyle's Law. Write the formula down and plug the numbers where they go. Let's see what we have. A gas has a volume of 5 liters, so I'm going to put that there. And the volume changes to 6 liters, so I'm going to plug it there. If the temperature is at 200 Kelvin, what is temperature 2? Now, I've got the numbers in position. Please listen. Notice the volumes match in units, temperatures match as well. It is just like Boyle's Law in that everything has to match in units. Liter, liter, they match, so I can use them. Kelvin, so I know my answer is going to come out in Kelvin. I know it will. So how do we solve fraction equals fraction? Well, from your algebra class, you know that you solve fraction equals fraction by cross multiplying. So what I see, and I'm just going to drop the units, 5 times x equals these two numbers. 200 times 6 is 1200. To solve this algebraically, I want to have x by itself, so I'm going to divide by 5. So I grab my handy-dandy calculator, and I'm going to do the same math I was doing the other day, 1200 divided by Excuse me, let me do that again. 1,200 divided by 5. 240 is the answer. 240 what? Well, if that's where the X is, this is Kelvin, so this is Kelvin. 240 Kelvin is my answer. It looks very similar to Boyle's law in that units have to match, but it is fraction equals fraction, so we solve it a little differently. Now, this is the answer I would have on paper if I'm doing it on the computer. I have to use sig figs, so let's check real quick. 1 sig fig, 1 sig fig. 200 has 1 sig fig. Those are both placeholders. 1 sig fig would stop at 2, so the answer, if I were doing it on the computer, is 200 Kelvin. And again, just like you did Boyle's law on the computer, you will do some Charles' law problems just to make sure you know what you're doing. This is the answer, 240 Kelvin, that I'm looking for on paper. That'd be great. This is how you get it right on the computer. Let's try another one real quick. Similar kind of problem. Let's say that we have a gas that has a volume of 610 milliliters and a temperature of 310 Kelvin. If the volume, what is volume 2 when the temperature changes to 178 Kelvin? Now I have to check my units first. Kelvin and Kelvin match. Volume, milliliters, so this one's going to come out eventually in milliliters down here. So I know that's what the unit's going to come in. So let's write the formula, V1 over T1, V2 over T2. Quick hint, the most common thing I see students make mistakes on, they don't write the formula, they just try to work it from memory. Plug the numbers where they go and see what you get so that you get it right every time. 610 milliliters, there's my X, 310 Kelvin, and 178 Kelvin. Just as a reminder, when you look at the units, we talked the other day, make sure you're looking. Milliliters is a unit of volume. I have it in the right place. Kelvin is a unit of temperature, so I have it with temperatures. Don't get them switched. If you get them switched, it'll mess up your math down here. How do I solve fraction equals fraction? Cross multiply. So what I see is 310 times X. 310 times X, that's those two, equals, I have to use my calculator, 610 times 178. It's a really big number. 108580. To keep the X, I'm going to divide by 310. So I'm going to divide by 310. My answer, 350.2, or if I'm doing one decimal place on my paper, that would round to a 3 milliliters. How do I know milliliters? They should match. Check my sig figs if I'm doing this on the computer. Original numbers, 2 sig figs, 2 sig figs, 3 sig figs. So I go with 2 sig figs. 1, 2, I stop my number there. 0 is a placeholder and I need it to get to the decimal. My answer would be 350 milliliters if I were on the computer. This is fine on a worksheet, but if I'm doing it on a computer, I need to make sure that I get the sig figs to get all credit. You guys are good at sig figs, so we just want to make sure we get it right when we're working on the computers. All right, couple of hints. Make sure you write your formula. It looks a little different from Boyle's law. To solve it, you're always going to cross multiply and solve for X. Your units have to match. Notice what's constant here? Pressure. You will notice there's no units in kilopascals, atmospheres, any of those things, because they're not in the formula. Pressure didn't change at all. The only thing that changed was volume and temperature. In the next video, you're going to practice some with me. Make sure that you practice them. Put some of these examples you see on the screen in your notes so that you have some examples. And then I'm going to come back and show you some things that might trick you when you work these. Good luck.